What is up, pre-algebra students? This is lesson 63. Our objective is working with rational numbers in different forms and also working with fractions that have negative exponents. We've already worked with negative exponents, but now we're going to be doing it with fractions. So first of all, let's talk about repeating decimals versus terminating decimals. If you have a number like 1/4, when we change it in a decimal, it comes out to be exactly 0.25. That's what we call a terminating decimal because it ends. But if you do something like 1/3, that comes out to be 0.3333. It keeps going on forever. That's what we call a repeating decimal. And we use a little bar above the part that repeats to show that it keeps going on forever, over and over again. So keeping that in mind, let's try example number 1. It says express 2/3 as an equivalent decimal and percent. Now, this word equivalent is important because it means you can't round. You have to put all of it. So you have to do something like this with the line above it. You can't just say 0.3. So let's see if we can say 2 divided by 3. Well, 3 doesn't fit into 2. So let's take and add on a 0. Well, 3 fits into 20 6 times, giving me 18. When I subtract, I get 2. Again, it doesn't fit in 2, so I'll have to add on the 0. And fits in that 6 times, I get 18. Subtract, I get 2. Notice you kind of see a pattern here. If it's in there 6 times, 18, I better not stop there with the 3 6s, oh my. So we'll do one more. There we go. See, and notice it keeps going on and over and over and again. It's going to keep getting 6s and 6s and 6s. So if we wanted to express it as a decimal, I could say 2/3 is equal to 0.6 with a repeating sign above that. If we want to write it as a percent, well, let's look back at this. Remember, a percent, you just multiply this by 100, which will move it over 2 decimal places. So it's going to be 66 2/3%, because this 6 keeps repeating on out here, right? So this part is the same thing as 2/3. So I got 66 2/3%. That's the exact. It says then, so we're not finished quite yet, express 2/3 as a decimal rounded to the nearest thousandths place. So I'm going to keep looking here. Notice this is the ones, this is the tens, this is the thousandths place. So 3 decimal places. So I'm doing the then in the red. So I'm going to say 2/3 is approximately equal to 0.66, and then we need to look. I'm cutting it off right here, and this number here is bigger than 5, so it's going to make that one round up. So it's going to be 667. Alright, example 2 says express 16 2/3 as a reduced fraction and as a decimal. So as a reduced fraction, so remember, if you want to change a decimal back to, a percent back to a decimal, you need to divide by 100. So we're going to have that 16 2/3 divided by 100. Well, that doesn't look like too much fun. Let's see if we can change the format there. 16 2/3 divided by 100 is a little better, which means 16 2/3 multiplied by 1/100th. So let's just change that left one into an improper fraction. 3 times 16 plus 2 over 3. So it's going to be 50 over 3 times 1 over 100. Go ahead and reduce that. 50 goes into 50 1 times and into 100 2 times. So I will have 1 times 1 on my numerator, which is just simply 1, and 3 times 2 in the denominator, which is 6. So that is my reduced fraction. Cha-ching. And then we remember and as a decimal. So if we want it as a decimal, I'm going to kind of skip here back to example 1. Remember, 2/3 is 0.6 repeating. So then I'm going to say 16.6 repeating, because that 2/3 is 0.6 repeating. And there, now we have a reduced fraction and as a decimal. Alright, arrange these numbers from least to greatest. Arrange these numbers from least to greatest. So let's go ahead and just convert them all, I think, into decimals. Convert them all into decimals. Well, this first one, let's see here. 4 divided by 5 doesn't go in there, so we'll add a decimal. Goes into that 8 times. So 4/5 is equal to 0.8. And I believe this one's supposed to be 0.83. I apologize for that. This one here, we're going to convert into a decimal as well, which somebody did kind of earlier. So we're going to divide that by 100, which is the same thing as multiplying by 1/100th. So 83 1/3 multiplied by 1/100th. Converting this left-hand part into an improper fraction. We get 250 over 3 times that 1/100. Again, we'll do 50. 50 goes into that 2 times. 50 goes into that 1, 2, 3, 4, 5 times. So this is going to be 5/6. I guess we're running a decimal of this, huh? Alright, so we're going to say 5 divided by 6. Doesn't go in there, so we'll have to add on a 0. 6 goes into 50 8 times, which is 48. Subtract, we get 2. Add on a 0, it goes into that. 3 times. 18, subtract, notice we get another 2. So that 3 is just going to keep repeating. So this one is 0.833333, etc. It keeps going on forever, forever, and ever. So notice this would be like an 8, 0. So this is going to be the smallest, so it's going to be the first one here. So I'd say 4/5. The next one is going to be 0.83. That's what this one should have been, 0.83. Because this one has another number past it, so it means it must be bigger. And then 83 1/3%. Alright, now the last thing we're working with here are negative exponents and fractions. Recall quickly, if you would, if you have x to the negative n, the same thing as 1 over x to the n. And also if you have a over b to the nth power, that's the same as a to the nth over b to the nth. So let's see if we can apply both these rules here and come up with a new rule. Notice this is going to be the same thing as 1 to the negative 3 over 2 to the negative 3 using this second rule here. And remember, negative exponents means I got to move them to the other side. So it's going to give me 2 cubed over 1 cubed, which if you notice is the same thing as what we started with, except for the inside is switched. See that? This is 1 over 2. So our new rule is if you have a over b to the negative n, that's the same thing as b over a to the nth power. So maybe write that down in your quick reference would probably be a good idea. This one here, we'll go and finish it out. 2 to the third power is 2 times 2 times 2, which is going to give me 8 over 1, which is the same thing as 8. That's part A there. Applying this rule here to part B, this is going to give me 10 over 1 squared, which is just really 10 squared, over 1 squared, which is just 1, which is 100. And part C, this is the same thing as saying 2 over 3, the first power, which is just the same thing as 2 over 3. Alright, your homework is there on page 432, 432. You're going to do the practice set, all the 63s from that lesson, and then 2 more of your choice.